Hi Year 6, welcome to your maths lesson for today. Let me share my screen and we can get started with today's Fast 5. Okay, so it's Thursday, the 4th of March 2021, and our learning objective today is to read increments on a scale. So today we are going to recap over some measurements today and tomorrow, in fact. But before we get on to that, can you have a go at the starter, where you will be just going over multiplying and dividing by 10, 100 and 1000. Pause the screen here and have a go, and then we'll go through this together. Great, how did it go? So we've got 3,458 and we are, 5 there. And we are dividing by 100. When we divide, our digits move to the right. And because it's by 100, we can see there's 2 zeros. That can be our little tip, that the digits move 2 spaces to the right. So our decimal points are there. And we are moving once, twice. So that's an 8 there. And then the 5 moves once. Oh, sorry. Once and then twice here. The 4 will move once and then twice over here. And the 3 would go once and then twice, where the 5 used to be in the tens column. So we've got 34.58. Well done if you got that correct. Let's look at the second one. We've got 500 and, no, we don't. We have 240 divided by 1,000. Remember, dividing by 1,000 will be moving the digits 3 places to the right. So we go 1, 2, 3. So the 0 goes there. 4 would go 1, 2, 3 here. 2 would go 1, 2, 3 places to the right. And we've got our decimal point here, and we need a placeholder, and so you should have got 0.24. We do not need 0 here as a placeholder, as there are no numbers after it, so 0.24 should have been your answer. 583 divided by 10, easy peasy. All of our digits move 1 place to the right, so that you should have got 58.3. Now we're multiplying by 1,000 and we're doing 0.54 multiplied by 1,000. When we multiply, we move our digits to the left. So let's do just that. And we're multiplying by 1,000, so it'd be 3 times with that we move our digits. So let's look at, because this is a 0 as a placeholder, we're not going to look at that one just yet. So we've got 5. And we're going to move that 1, 2, 3 places there. So that's a 5. And our 4 goes 1, 2, 3 places next to the 5. We have nothing here, so I'll put a placeholder there. And we don't have any numbers here. So our answer would be 540 for that one. And hopefully if you applied the same method, you would have got, for question 5, 4.35 multiplied by 100, you should have got 435. Well done, everybody. Now let's move on to the big question. So, like I said, we're going to be recapping some measurements, okay? But with a focus on reading scales and increments. What can you see with these 3 pictures? What's the same and what's different between these 3 pictures? Pause the screen and have a think. And then when you're done, I'll discuss some ideas. Great, so hopefully you would have said that that this is a number line, and it technically isn't really measuring anything, like the way that this jug is measuring liters, you can see, and milliliters, and the scales are measuring kilograms. Okay, so these are measuring certain things, whereas this is just a number line. But hopefully you recognize that they all have these lines that that increase each time you move up or across or around. Okay, so from left to right or bottom to top. Okay, and you can see they all have increments here. Okay, these lines. Well done if you spotted that. Let's look at some vocabulary. So you probably heard me saying some of these words during the big question. And you definitely have seen these words in the learning objective, which is to read increments on a scale. So an increment is a small equivalent interval. So for example, on the number line, even though it's not measuring anything per se, it's going up in equal jumps. Each jump is worth, what's that? 0 to 1 is worth 1. 1 to 2 is worth 1. 2 to 3 is worth 1. What about -2 to -1? This jump here is also 1. Okay, so it's this idea that we, from each line, so from each increment, it jumps up in equal amounts. Okay, and we're reading increments on a scale. And a scale, yes, we have weighing scales, but in this context, a scale is a system which uses the intervals. Okay, so just like how we go from 0 to 1,000 milliliters, here, this is a scale from 0 to 1,000 milliliters. This is a scale from -6 to 7. This is a scale from 0 kilograms all the way to 150 kilograms. So that's our scale, okay? But the little lines in between are called increments. Well done. Okay, let's have a quick recap of our conversion facts. So when we go from millimeters to centimeters, we divide by 10 because there are 10 millimeters in a centimeter. Going from centimeters to meters, we divide by 100 because there are 100 centimeters in a meter. And when we go from meters to kilometers, we divide by 1,000 because there are 1,000 meters in a kilometer. And going backwards from a larger unit to a smaller unit, all we do is the inverse of what we did going forwards, okay? And the same applies with the rest of these. Remember, there are 1,000 grams in a kilogram, so we divide by 1,000. And there are 1,000 kilograms in a ton, so we divide by 1,000 there as well. And we do the inverse going backwards. Just like milliliters to liters, we have 1,000 milliliters in 1 liter, so we divide by 1,000. And the inverse would be multiplying by 1,000, which gets us from liters to milliliters. Okay, so I'm going to have a go at this question here. What I want you to do, just have in mind our learning objective. We are learning to read increments, okay, on a scale. That's the objective for today's lesson. So have a think about what my steps are when I am answering this question. So the scale says, look at these scales. Sorry, the question says, look at these scales. What is the mass of the chick? Okay, and it's asking me to put my answer in grams. Well, okay, so the scale is saying that it's going, it's measuring in grams anyway, so I don't need to convert anything here. Right, let me have a look at my scale first. So it's going from 0 to 250 grams. Now, looking at the jumps of the numbers I can see, it's going up in 50. So from 0 to 50 is 50. 50 to 100 is a 50. 100 to 150 is also 50. So it's definitely going up in 50 grams. Okay, so now that I know it's going up in 50s, let me count and see how close I can get to my arrow. Okay, so it goes 50, 100, 150. And because the arrow isn't past my 200, I'm not going to count that. All I know at the moment, the mass is pointing here at this increment there. And at the moment, I'm just under it at 150 grams. To be able to work out how much more this mass is, I'm going to have to work out what each individual increment is worth. And the way we do that is we have to see, if we look at our 50-gram jump, let's see how many lines there are, how many increments there are between 0 and 50, okay? So if we count together, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, because there are 10 even increments, equal sized increments, I'm going to just divide 50 by 10 to get equal parts. And 50 divided by 10 gives us 5 grams. So this is 50 grams divided by 10. So that means each individual, you can see that, that's a little arrow there. Each individual jump here is worth 5 grams. It's going up in 5 grams. Okay, so if that's the case, now I've got from 0 to 150. If that's the case, that each increment is 5 grams, let me count up. So 150, 155, 160, 165. And that's where my mass is pointing at. So hopefully you should have, if you were following with me, you should have also counted 165 grams. And that is the mass of the bird. Okay, so hopefully you maybe made some mental notes or written notes of my thought process and what I was doing there. What I'd like you to do is have a go at answering question A first. Okay, it says use the scale to find the length of Joe's key. So you're finding the length, you're looking at centimeters. So think back, how many millimeters are there in a centimeter? If you're a bit stuck, count your increments and try to work out how long the key is. Pause the screen and have a go. Okay, so hopefully you would have realized that each increment is going up in 0.1. You should have got that by dividing 1, so that's our big jump, and we're dividing that by 10 because there are 10 equal lines here, and 1 divided by 10 gives us 0.1. So each increment, I'll put I, equals 0.1, and in this case, millimeters. Okay, so because it's going up in 0.1, I can then count up in 0.1 from 5. So 5, 5.1, 5.2, 5.3, okay? And that's how long the key is, 5.3 centimeters. Brilliant. Pause the screen and have a go at the second part of this question. So now the key, so we have to use this information. The length of the key is 5.3 centimeters, but now the key has shifted along the ruler and the start of the key is here, but we can't see the rest of the key. It says one end is at 2.8 centimeters, so it tells you this is 2.8 centimeters. Where is the other end of the scale? So at what number does the end of the key reach? So pause the screen, have a go, and press play, and we'll go through the answer together. Okay, so we know that it starts at 2.8 centimeters, and we can use our knowledge of the length of the key, which we found in part A. And the length of the key is 5.3. So if we are starting at 2.8 and the length is 5.3, so from here all the way to, I don't know, maybe here is 5.3 centimeters. How can I work out what this point here is, where the end of the key reaches? Well done if you said we need to add 5.3 to 2.8, okay? So let's do that together. 5.3 plus 2.8, 8 plus 3 is 11. 2 plus 5 is 7, plus the 1 is 8. And our decimal point goes there. So hopefully you got 8.1 centimeters. And that's where the key reaches over here. Okay, so that should be 8.1 centimeters. Brilliant, let's move on. So what I'd like you to do is, using all of these skills we've discussed in those 2 questions, can you please have a go at finding the values of where the 2 arrows are pointing to? Okay, so pause the screen, have a go, and then we'll go through the answers together. Okay, so we can see that our scale is from 0 to 5, and it's in kilograms, okay? 0 to 5 kilograms, that's our scale. Now we have to work out how much each individual increment is going up in. Well, we can see from, if we count from 0 all the way to 5 and see how many increments there are, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, because the scale is going from 0 to 5, and 5 is at the end here, we can do 5 divided by the number of increments to find out how much one equal part is, okay? So there's 10 increments, we're going to do 5 divided by 10, and you should have got 0.5 kilograms. So that's 1 increment's worth. So hopefully you would have realized that, oh, the first increment is where the first arrow is. So this is 0.5 kilograms. If we count up in 0.5s to see what this arrow is pointing at, we can then find out what the missing value is. So 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4. So this number should have been 4 kilograms. Now, in some of your questions, don't forget to write the units with your answers. Okay, let's have a look at the success criteria. So, to be successful in achieving our learning objective today, you will have to do the following. You're going to need to highlight keywords. And I know online you can't really highlight, so maybe write down the keywords. That might help you even more. Calculate how much one increment goes up by. So remember, we looked at what our scale is from the 0 to the first unit we can see, and we see how many increments there are, and divide our first unit by the number of increments to find the equal parts. Okay, remember, increments are equal parts. They go up in equal amounts. Calculate how many increments there are in the bigger measurement. So that will help you with some of the questions. So for example, there are 10 millimeters in 1 centimeter. So that's calculating how many increments there are in a bigger measurement, okay? I'll put that here, e.g. 10 millimeters in 1 centimeter, okay? And then finally, choose the correct operation to calculate your answer. So you're gonna have a series of questions to answer, and hopefully the success criteria will help you to understand your method in answering these questions. So your operations, just to remind you, if you are doing conversions, so here we've said choose the correct operation. If you are doing conversions, you're going to need to multiply or divide. If you are doing, if you're finding a difference, you're subtracting, and if you're finding a total, you're adding. Okay. So just remember all of that, and if you can't, remember that you can always come back to the video and have a look here. Okay. Feel free to use the conversion facts here to help you as well. But if you'd want a challenge, try not to look at this. So I will leave you there. Can you please head on over to Teams to complete today's assignment? Again, refer back to the success criteria to help you with your methods, and use the conversion facts. It's also saved on Teams in the maths file as well, or you can just look at the video here. I will leave you there, and I will see you next time. Goodbye.